In this video, I want to talk about properties of proportions. But in order to do that, we need to define a few things first. So first, let's define ratios. Now, what's a ratio? A ratio is a comparison of two quantities. Comparison of two quantities. Okay, what could that look like? Well, we want to compare two things that have some sort of number attached to them. So at Anderson, we have 3 geometry teachers, and we have about 150 geometry students. So the ratio of geometry teachers to geometry students is 3. That reads 3 to 150. Now you could also, so you could write it like that, or you could write it like this, 3 over 150, because there's 3 geometry teachers for every 150 students. So there's multiple ways to write a ratio. Now, when we're writing ratios, we need to be cognizant or aware of our units, because oftentimes it's easier to compare two things if we have the same unit. So let's look at this example. If I'm finding the ratio of length to width, where my length is 4 meters and my width is 180 centimeters. Okay, so here we have 4 meters to 180 centimeters. Now, when I'm looking at this, well, part of it's just because we don't use meters and centimeters a lot, but that doesn't give me a clear idea of the actual comparison. So let's see if we can simplify here. So 4 meters to 180 centimeters, 4 meters is the same as 400 centimeters, right? So that same ratio would be 400 centimeters to 180 centimeters. Now let's see if we can simplify this even further. And you could think about this, right, like the fractional form that we saw earlier, 400 over 180. If we simplify that, well, the zeros go away. 40 and 18 simplifies to 20 centimeters over 9 centimeters. So length to width was 4 meters to 180 centimeters, but we can kind of shrink that down and get it simplified into 20 centimeters to 9 centimeters. It's a little bit more, I'd say it's more precise, right? So precision is really nice here. And even up here, right, we have 3 geometry teachers to 150 students. You might say, well, that's the same as for every 1 geometry teacher, there's 50 students. So simplifying can help us have a more clear picture of the ratio that we're dealing with, right? Okay, so those are ratios. Now, the reason we need to define ratios is because a proportion is a how do I want to say this? It's not a comparison of 2 ratios. It's a proportion is, it's really just 2 equivalent ratios. That's what a proportion is. Yeah. So like here, a proportion, we could say the geometry teachers, right? 3 over 150 equals 1 over 50. That's a proportion. Now, you might say that doesn't seem all that helpful, but when we start getting variables involved, that's where it's useful. So generally, when I write a proportion, or if we're talking about proportions in general, it looks like this. A over B equals C over D, right? That's a proportion. I have a number over another number that's equal to another number over even another number. That's a proportion. Okay. Now, I'm just going to go ahead and say this. Cross multiply, I have problems with it. Okay? I have problems with cross multiplying because it's not rigorous. It's not mathematical. But it is an easy way to talk about what we call the cross product, or an easy way to get the denominator out of fractions. So if I have a proportion A over B equals C over D, and I don't want any denominators. That's where this idea of cross multiplying comes in handy. Okay, so if I wanted to get rid of this denominator, well, let's start here, a over b. What would I need to multiply by to get rid of b in the denominator? Well, I need to multiply by b, right? B times a over b. And since I multiplied this side by b, well, I also need to multiply this side by b. Okay, okay, so that would get rid of that denominator. Now, how could I get rid of the denominator on this side where I have c divided by d? Well, if I multiply by d on this, well, if I multiply by d, that'll get rid of that denominator, and what I do to one side, I need to do to the other. So if we look at this, d cancels out here, b cancels out here, and what I'm left with is AD equal to BC, or DA equal to CB. It's the same idea, right? And that is, if you have a proportion that's A over B equals C over D, I also know that A times D is equal to B times C. Okay, so we shorten that by saying A over B equals C over D. Well, I can just cross multiply, right? I can just cross multiply. Some people call this the butterfly method. I can multiply A times D and B times C, and that will give me this. But cross multiplication only works when there's an equal sign, so I'd rather you think about it as multiplying out the denominators. Right? I kind of want you to unlearn cross multiplication a little bit and think about it more as you're multiplying both sides by both of the denominators. But as I go through these notes, I inevitably will talk about cross multiplication or finding the cross product because, well, the bottom line is it's a little bit quicker, right? It's more expedient, takes less steps. Okay, so let's do some examples with cross multiplication. Okay, find the value of x. 3 over 7 equals 5 over x. Now, again, if I want to think about this as multiplying both sides by the denominators, here I would multiply this side by 7, and whatever I do to this side, I have to do to this side. Here I would multiply this side by x. Whatever I do to that side, I have to do to this side. So the 7's cancel, the x's cancel, and I'm left with 3x equal to 5 times 7 is 35. Divide by 3 on both sides, and x is 35 over 3. Not too bad. Okay, you're saying, Mr. Dussault, I just want to cross multiply, right? I love cross multiplication. Okay, let's try one where we cross multiply. 3x plus 4 over 6 equals 2 over 5. I multiply this numerator by this denominator, so 5 times 3x plus 4. And here I do the same thing, 6 and 2, we'll just write it. So 5 times 3x plus 4 and 2 times 6. So now I want to distribute my 5 here. I'm kind of checking and seeing, could I divide both sides by 5? But there's no common factors there, so let's distribute. 15x plus 20 equals 12. We need to subtract 20 from both sides. 15x is equal to negative 8. So divide by 15, and you'll notice we're getting kind of some weird answers here, but that's okay. X equals negative 8 over 15. Okay, so there you have it. That's cross multiplication. And if we're comparing two proportions, they should have equivalent cross products. Okay, so, and that doesn't mean that they'll always, it's kind of tricky. It doesn't mean that they'll look always exactly the same, but we know that their cross products are equal. So an example here, if A over B equals C over D, then does A over D equal C over B? We can check that by looking at the cross product, right? Because here, I don't know, it's just what our brains, the way that they work, or at least the way my brain works, it's harder for me to say, just looking at this, A over B equals C over D, is that the same as A over D equals C over B? My brain, it's hard for my brain to tell. So let's cross multiply here. Again, we're multiplying by the denominators, but it's just so much easier to say cross multiply, right? A times D equals B times C. And over here, if I cross multiply, A times B equals C times D. So are these the same? AD equals BC and AB equals CD? Well, no, they're not, right? Here I have the product of A and D. Here I have the product of A and B. So unless B and D are equal, which we're assuming they're not, because otherwise we would just call it B, right? These are different. We're assuming that all of these are different numbers. And maybe that's worth saying, right? A is not B, is not C, is not D. None of those are equal to each other. So these cross products are not the same. All right, let's look at the addition property of proportions. We've got two properties left. The addition property of proportions, well, if we start with this, A over B equals C over D. The addition property of proportions is equivalent to adding 1 to both sides. We're adding the same thing to both sides, but it's going to look a little bit different. So the equivalent, if this, then here's the property right here. A plus B over B equals C plus D over D. Now, why does that work? Well, let's take this. I have A over B. And what would it look like to get B in the top? Well, if I added B over B, right, then my denominator would stay the same and my numerator would be A plus B. Okay, now, B divided by B is just 1, right? I am changing this side. I am changing the value of my left-hand side, but I'm adding 1, okay? And now, so if I added 1 to this side, I want to add 1 to C over D. Now, what's a clever form of 1 that I could add to C over D? Well, if I add D divided by D, right, this is still 1. Right, this might be 5 over 5 and this might be 10 over 10, but they're both equal to 1. So I'm adding the same thing to both sides. And when I do that, we add the numerators. So A plus B, the denominator stays the same. We add the numerators, the denominator stays the same. And that is the addition property of proportions. So this is like adding 1 to both sides. That's basically what we're doing here. Okay, so if we wanted to write a new proportion using the addition property, 5 over 13 equals 20 over 52. I'm just adding the denominator, 5 over 13. I'm adding 1 to both sides. Right? And this is the same thing as saying 5 plus 13 over 13 equals 20 plus 52 over 52. Right? And this first step's not really necessary, but I just wanted to remind you that we are adding 1 to both sides. I'm not adding 13 to both sides. I'm really just adding 1. Okay. So then 5 plus 13 is 18 over 13 equals 72 over 52. So this is an equivalent proportion. Well, I guess this is also a true proportion. Since this is true, this is also true. Yeah. And you could prove that by checking the cross product. If I do the cross product here, my cross product should be equal. If I do it here, these cross products will also be equal. So they won't be the same, but they'll be equal. Well, they won't be the same anyways. Yes, you can check it by checking the cross product and seeing if this is equal. All right. The subtraction property it's the same idea. Instead we subtract 1 from both sides. That's the idea of the subtraction property. So if A over B equals C over D, then A minus B over B equals C minus D over D. So if I wanted to do an example with this, x over 3 equals 7 over 2. That's just x minus 3 over 3, right? Subtract the denominator, equals 7 minus 2 over 2. Well, we can do 7 minus 2. So x minus 3 over 3 equals 5 over 2. Now, I'm not asked to solve for x. I'm not asked to solve for x, but x would be the same here as it would be here. Okay, so those are some properties of proportions. We defined ratio. We defined what a ratio is. We defined what a proportion is. And we went through the properties. We've got the cross product is the same. The addition property, we're adding 1 to both sides. And the subtraction property, we subtract 1 from both sides.